Hi, calculus students. These notes are on the chain rule, and I'm counting these are level 2 examples, so they are harder than the ones we've done so far. They sometimes involve another rule or 2 chain rules, so it's kind of about recognizing the underlying structures and then applying the rules, but it's a little bit more complex than what we're used to. So it's going to run through some examples, and we will be practicing next time I see you. So the first one is h of x equals secant to the 4th power of 6x plus 3. Whenever you see the exponent before in a trig function that's before like what you're taking secant of, we can always rewrite that. That's equivalent to secant of 6x plus 3, and then we can kind of think all raised to the 4th power. And rewriting it allows us to kind of see what is the outermost function, and it's not secant, but it's something to the 4th power. So if I'm doing the chain rule here, I would say my f function is x to the 4th power, and then my g function is what's inside, so secant of 6x plus 3. Now, what I'm noticing already is that this in and of itself is a composite function that requires the chain rule. So this is a situation where I'm actually going to need to do like a double chain rule. Okay? So this is, I'm just going to kind of do like a little sidebar here to say that what's going on is a double chain rule. Okay, so I'm going to set it up the same way and then until I get to g prime, but f prime is 4x to the 3rd. Now, to know what g prime is, I need to do a chain rule here. Now, this might be a chain rule that's easy to do without writing out f and g, but I would encourage you, if you need to take what I'm going to call like a sidebar, and set up like another f and g. Now, this is like a mini problem to give me my g prime here. So in that case, the outer function here is secant of x, and the inner function is 6x plus 3. So then f prime is secant x tan x, and g prime is just 6. So from this sidebar, I can fill in my g prime, and then I'll be able to use this information to get my overall h prime. Okay, so the idea would be, and for both of these x's, I'm plugging in my 6x plus 3, so let's see if I have enough space here, and then I'm multiplying it by 6. I might as well just do that 6 up front, so it would be 6 secant of 6x plus 3 times tangent of 6x plus 3. And that's the derivative of g prime. So now, coming back to my original problem, I should get h prime of x is equal to the derivative of f, where I plug in g in for that x, so that would be 4 parentheses secant of 6x plus 3 to the 3rd power. So I'm going to actually put that 3rd power there. So I don't really need that parenthesis, but since I drew it, might as well put it. Okay, so then times the derivative here, which is 6 secant 6x plus 3 tangent 6x plus 3. Now, this is a whole bunch of stuff. I can make this look a little bit nicer if first of all, I have my numbers, so I could multiply 4 and 6. And then the other thing I notice is that I have like a secant of 6x plus 3 to the 3rd, and then I have another secant of 6x plus 3, so that becomes secant to the 4th power of 6x plus 3. So fully simplified, I could have 24 secant to the 4th power of 6x plus 3 times tangent of 6x plus 3. So again, we should always be looking to do some basic simplification like that. Okay, let's look at another example. So my next example is y equals t plus 3 over t squared minus 4 to the 6th power. So you might notice here that there's a quotient. We have a fraction inside as our inside function. So this is going to require the quotient rule, right? So the key thing to recognize is, what will you set up first? Will you set up the chain rule first or the quotient rule first? And I start with the thing that's kind of like the outermost thing. So I'd say the outermost thing happening is chain rule, and then you'll have to use the quotient rule. So it's kind of like make a note. We'll say chain, then quotient. So what does this look like? I'm going to say f is my outer function, x to the 6th. G is my inner function. And I mean, technically, since I have t's here, I guess I should have a t here, but it doesn't matter too much, but I'm going to use t's. So t to the 6th. And here I would have t plus 3 over t squared minus 4. Now, to get f prime, it's just 6t to the 5th. But to get g prime, I have to set up the quotient rule, right? So this is where I could do a sidebar. I'm not going to require you to write sidebar every time you do it, but just kind of like to narrate my thought process. So I would say u is t plus 3, v is t squared minus 4, so u prime is 1 and v prime is 2t. So setting up the quotient here, I would get, I start with v, so that's t squared minus 4 times u prime, that's just 1, minus u, t plus 3 times v prime, 2t, all over v squared, so that's t squared plus minus 4 squared. And there's some simplification I can do here, and I'm going to do it just so I can kind of consolidate terms on top. So I can distribute the 2t inside, and that would become, I'll rewrite it, okay. That becomes, so t squared minus 4 minus 2t squared, and I'm going to kind of do two things at once, which is distribute the negative and distribute that 2t, so minus 6t all over t squared minus 4 squared, and that's the same thing as negative t squared minus 6t minus 4 over t squared minus 4 squared. Okay, so all of that was just to get this g prime, but now I need to kind of come back to my original chain rule setup and say, okay, so it should be the derivative of f with this plugged in for t times this other derivative of g prime, okay? So putting it all together, we get y prime is equal to 6 t plus 3 over t squared minus 4 to the 5th. So this part, I don't know if you can see what I'm doing. Okay, there we go. So this is just f prime of g of x, right? Where I plug this in for that t, and now I need to multiply it by my derivative of g prime, my derivative of g, which is g prime. So times negative t squared minus 6t minus 4 all over t squared minus 4 squared. There's not so much simplification that I can do here. The one simplification I could do would be like distribute the exponent of 5 to top and bottom here, which would become like t plus 3 to the 5th over t squared minus 4 to the 5th. And what that will do is allow me to basically combine these two denominators, because it's like a t squared minus 4 to the 5th times t squared minus 4 to the 2nd. So I can add those exponents and get a t squared minus 4 to the 7th in my denominator, and then I would just like have all of these pieces in my numerator. And that's about as simplified as it would get. So it would look like 6 times t plus 3 to the 5th times negative t squared minus 6t minus 4 all over t squared minus 4 to the 7th power. Okay, so moving on to the next example. My next example is h of x equals 2x times tan of x to the 4th. So this one is one where it's important to kind of see the underlying structure. I can see that I have tan of some other function, so I can kind of see this is a composite function, but I see overall I have multiplication of 2x times this composite function, right? So the key thing to recognize here is that I'm going to need to do product first and then the chain rule. Okay, so product, then chain. So what does that look like? That looks like setting up my u and my v functions, right? So u would be 2x, v would be tan of x to the fourth, u prime equals 2. Now, to get v prime, you may be able to do this without writing out your f and your inside and outside functions f and g. You might be able to kind of visualize, oh, it's tan, the derivative of tan is secant squared of that times the derivative of the inside. But I'm going to show the sidebar just in case anyone is having a hard time. So my sidebar would be f is tan of x and g is x to the fourth. So f prime is secant squared of x and g prime is 4x to the third. So from there, plug in x to the fourth for that x, so I get secant squared of x to the fourth times 4x to the third. And to make it look a little nicer, I might write the 4x to the third first. I'll do that at my next step. But there's not more simplification I could really do here. But at that point, now I'm just going to set up the product rule. So I'm going to say h prime of x equals, so it should be u times v prime. So I'm going to do something in my head, which is 2x times 4x to the third should be 8x to the fourth times secant squared of x to the fourth. So that's this times this, plus this times that. 2 times tan of x to the fourth. Okay? And that would be my final answer. I can't really simplify that anymore. Okay, one more example for you guys, and then I'll give you one to try. So let's say y equals 2x plus 4 squared over 3x. So the key here, if you're looking at the overall structure, is like, do you want to do chain rule first? Is it overall chain or is it overall something else? And I see like overall, it is a quotient. It's something divided by something else. So what that's telling me is I should start with the quotient rule, and then I might need to use the chain rule when I deal with my numerator. So if I'm doing quotient rule, then I need a u and a v. My u is 2x plus 4 squared. My v is 3x. U prime, that's where I'm going to need the chain rule, right? So sidebar for my chain rule, or maybe that's a pretty straightforward one, so you might just be able to think about power rule, bringing the 2 out front and multiplying by the derivative. But if not, you can always set up your f and your g. So here f would be x squared and g would be 2x plus 4. So f prime is 2x and g prime is 2. So that gives me this, plugging that in for that x, so that gives me 2 times 2x plus 4 times 2. That's the derivative of g. So that gives me, I'm basically distributing a 4 into here, right? So that gives me 8x plus 16 for u prime, and then v prime is just 3. So now, setting up my derivative, I start with v times u prime, so that's 3x times 8x plus 16 minus u times v prime, so that's 3 2x plus 4 squared all over v squared, so that's 9x squared. Now, at this point, I'm thinking about simplifying. One thing that I notice is that there's a 3 there, a 3 there, and this is a 9, right? So I could divide a 3 out from all of them. And then I could also distribute this x in. So that would give me 8x squared plus 16x minus 2x plus 4 squared over, since I divided that by 3, it would be 3x squared. And like, I could keep going here. It's not so hard to expand this and then combine like terms. I'm gonna stop there, but just know that if you needed to, it's not so bad to simplify this a little bit further. Okay, so now let me give you guys a u-try problem. I'm gonna give you guys 2 u-try problems. The first one is going to be sine squared of x to the third plus 2x. Y equals that. And in case you're wondering, I'll give you a hint. This is a double chain rule. And then let's do secant squared of x times x squared plus 3x minus 7. Okay, and that one is I'm not going to tell you, but it involves the product rule and the chain rule, but you need to think about in what order you need to do them. Okay, and I forget my y equals again. So here are 2 problems for you to try, and we will be practicing this next time I see you.